Okay, so here's the deal. What's the simplest thing that makes a base?
Hydroxide.
Hydroxide. But not all bases have hydroxide. Many, 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 many bases don't have hydroxide. You can act as a base in a different way. There are actually 3 definitions, 2 of which we're going to cover in this class. The simplest one is the definition wherein hydroxide makes a base. The more complicated definition is something that takes H plus. All right? Something that takes H plus is a base. Give you a simple example. HCl plus, what would be something good here? Well, we could say the acetate on now. How about ammonia? All right? Reacts. What will happen is we'll get NH4 and chlorine. This reaction really does happen. Okay. Which one of these 2 is the acid? Better get this one right. We just shouted about it. All right, HCl, that's the acid. Which one of these is the base?
Ammonia.
Ammonia. Let's use a more. Now this is good. All right. Does that make sense? Now watch. What if I reverse the reaction? This doesn't happen freely. Which one of these acted like an acid? Which one gave away an H?
NH4.
NH4 became NH3. Agreed?
Mm-hmm.
So NH4 is an acid. In this reaction, it's acting like an acid. What's the chlorine?
Base.
It's acting like a base. Good? Now, you may have discussed this in first year chem. If you look at the first reaction, notice that NH4 has become effectively an acid, or could be an acid, and Cl minus could be a base now. True? Okay? So what they cool that is they say ammonium ion is the conjugate acid to NH3. And these 2 are considered a pair. That's a base, that's its conjugate acid. Same thing here. HCl was an acid. Chlorine is considered to be its conjugate base. See it? Pretty simple. So any conjugate acid-base pair differs by an H. I'll say that again. A conjugate acid-base pair differs by an H. This is my acid, H2S. What's its conjugate base?
Acid.
Nope.
HS.
HS, but notice you lost an H plus in the process, so what's the charge on HS? -1. Does everybody see that? If that is an acid, it loses an H and becomes HS minus. Okay? If I said NH4 plus is my acid, what's my conjugate base? NH3. It lost an H plus, so it's neutral. If ammonia, the gas, NH3, acts like an acid, what's its conjugate base? NH2 minus. Are you seeing it? Yes, ma'am.
Can you explain the charges on the conjugate basis?
Absolutely. So what you're losing is you're losing an H which is positive. So if this was neutral, it's now lost one positive charge, so it's now negative. This one, it was positive 1, it's lost one positive charge, it's now neutral. This one was neutral, it's lost one positive charge, it's now negative. If I were to do HS minus as the acid, what's its conjugate base? Lost one H, lost one charge.
S minus 2.
S, 2
Or
minus.
two.
Comprenez-vous? Okay, so could you effectively reverse this chart? If I said this is a base, its conjugate acid is this. Those are conjugate acid base pairs. Question?
Just in the last one, wait, so you lost the H, but why is there two total?
Okay, because you were already minus 1.
Mm-hmm.
You lost another positive.
But I thought you just lost the H.
You did, but you lost an H plus. You're losing a proton effectively, so you're losing an H, and you're also losing one more positive charge. Okay?
Okay.
Yeah.
So every time you lose an H, you always just like take one positive, like it's just gonna be like one negative, like.
One more negative.
Okay.
And of course, it's totally backward because if it made any sense, if you lost something, you become more negative, but when you lose something, you become more positive. But if you lose H pluses, you become more negative. So, yeah, isn't that a pain in the tuchus? All right. Questions, problems, concerns?